Welcome back to the channel. In today's video, we will explain how to work out the forces that need to be resisted by the restraints to prevent lateral torsional buckling. Steel beams have a tendency to buckle along their length. In the case of simply supported beams, this is prevented by restraining its compression flange, which prevents it from rotating along its axis. This phenomenon, known as lateral torsional buckling, must be fully understood and allowed for by the structural engineer when designing structures that consist primarily of steel elements. In order for a steel beam element to be classed as restrained, its compression flange must have sufficient restraints so as not to be susceptible to lateral torsional buckling. As a general rule, a restraint to a top flange of a beam must be capable of resisting a force that is equivalent to 2.5% of the ultimate compression load in the top flange of the beam element it is restraining. Taking a simple example, we have 8 meters long, 610 by 305 by 149 UB, is supporting UDL of 20 kilonewtons per meter ultimate load, and lateral restraints at third points along its length. The question is how to calculate the axial force that needs to be resisted by the restraints. For 610 by 305 by 149 universal beam, we have the following properties. First of all, we need to work out the ultimate bending moment, which equals 20 kilonewtons per meter times span 8 meters squared divided by 8. This gives us a value of 160 kilonewtons meter. Next step, we need to work out the compression stress in flange, which equals bending moment 160 kilonewton meter divided by elastic modulus 4110 cubic centimeters. We need to multiply by 1000, so we will have a value of 39 newton per square millimeters. Next, we will work out the compression force, which equals compression stress 39 newton per square millimeters, times beam width, 304.8 millimeters, times flange thickness, 19.7 millimeters. We should divide by 1000 to convert newton to kilonewton. This gives us a value of 233.75 kilonewtons. As we mentioned, a restraint to a top flange of a beam must be capable of resisting a force that is equivalent to 2.5% of the ultimate compression load in the top flange of the beam element it is restraining. Therefore, 2.5% of compression force equals 2.5 divided by 100 times 233.75 kilonewtons. This gives us a value of 5.85 kilonewtons. As a result, the total force needed to be resisted equals 5.85 kilonewtons divided by 2, which is equal to 2.925 kilonewtons. Thanks for watching. We hope you found some useful tips. Check out our website at structuralengineercalcs.com. Please like and subscribe, and let us know what would you like to see next. The human footprint is a masterpiece of engineering and a work of art. Stay safe. Goodbye, and see you soon.